So I'm Sandra Charlotta. I am the Assistant Director of Administration for Cooperative Mobility of Competitive Megaregions, CM2. We are here today for our February BrownBag presentation. We have monthly presentations from our CM2 researchers and students that is transportation focused. And we are really happy to have our first presentation of spring 2022 be with Josh Davidson of UPenn. I'd also like to say hello to Dr. Ming Zhang, who is the director of CM2. Thank you for joining us. And Dr. Megan Ryanson from Penn, thank you also for joining us. So just to, again, kind of briefly go over our agenda, I'm going to be introducing Josh and his presentation. Josh will be presenting, and then we'll have a short Q&A afterwards. So Josh's presentation title is Measuring Change in Bike Share Use, a raster-based, open-sourced, and open data approach. And I also just wanted to make mention that we, once again, congratulations to Josh for being our nominated Outstanding Student of the Year awardee. So every year, the Council of University Transportation Centers, CUTC, awards students with this award recognition. There is an awards reception banquet at the annual TRB meeting in Washington, D.C. in January of each year. And we were so glad to nominate and have Josh go to the TRB meeting. So I know some of my Q&A will actually be your updates from your experience at TRB. We'd love to hear it. So once again, we are very proud that we were able to sponsor Josh's trip up there. And we're very glad to have you presenting today. So thank you again. I'll go ahead and turn it over to you for your presentation. Thanks, Josh.
Sandra, thanks so much. It's really awesome to be here. I would just say, like, specifically, like, CM2 has been hugely supportive of my work since I came into the doctoral program at Penn. I also just want to say more broadly, like, the work coming out of UT Austin in the transportation world is truly admirable and really has been formative for my own thinking. So it's an honor to get to speak here, both in the context of the CM2 and in the context of the University of Texas at large. Sandra, to your point about TRB, I'm hoping I'm going to start the presentation with a little recap of, like, what I talked about at TRB, the presentation that I gave there and how it was received, and then I'll move into the paper proper. So I'll share my screen now and we can go into it. Let me make this full screen. All right, is everybody, slides are up here? Okay, great. So I'll be giving a talk today, as Sandra said, on measuring changes in bike share use, a raster-based, open source and open data approach. The first thing I'm going to talk about is the CM2 supported work that I presented at TRB, and which wonderfully, like, in the last 2 weeks before TRB happened, Rebecca Sanders, who's the chair of the bicycle committee, reached out and asked that I present the work in a lightning round talk at the bicycle committee meeting. I guess it was chosen as one of the top papers in the bicycle committee for this year. So that was a really wonderful little extra opportunity that, again, my deep gratitude to the CM2 for supporting me getting to TRB and being able to share this work in that space. So I'm going to share a little bit about that presentation, and then I'll move in to the body of the paper that I'm working on right now, and would love to, like, hear anybody's thoughts about that work as it develops. So what happened at TRB? I presented a paper that's co-authored between myself, Dr. Ryerson, and then a number of really phenomenal undergraduate colleagues that have been working in the lab over the course of the last 2 years, looking at how to measure the equity impacts of the COVID-19 pandemic on bike share use and use patterns in Philadelphia, Pennsylvania. The 2 questions that we asked was, what is the effect of the pandemic on average daily trip durations? And how does this effect differ across population groups? You're going to hear me talk a lot about trip duration over the course of this presentation and both papers. But the rationale we have for looking at trip duration is that while trip frequency might measure the magnitude of use over a given amount of time, we suggest that trip duration is a really good measure of the intensity of use. And the intensity of use is an important policy metric in that folks who are using folks who are taking longer trips probably are engaging in one of two behaviors. One, if they're experienced cyclists, they're taking farther flung trips, which has policy implications for the system and the system's reach. Or if they're less experienced cyclists, they might be bicycling slower, but the fact that they're using the system more in a pandemic period has implications for bike share policy and really for mobility policy period in an urban context. And then we look specifically at how the effect of the pandemic on trip durations differs across population groups, which we proxy by Philadelphia's planning districts, which are very sociodemographically and economically differentiated one from the other. We use an interrupted time series approach to conduct the study, and we fit models both at the whole bike share system level and then at each of the planning districts. And the model specifications are rather simple, but I think quite interesting one where we just look at trip duration as a function of time, this treatment, which is the beginning of the pandemic, an interaction term between time and the pandemic period, and then we control for seasonality by looking at the month of year in which the data was collected. So this is the time series trend smoothed out using a 7-day rolling average of the average daily bike share trip durations. And the main thing to sort of orient is just the magnitude of difference in this initial period of the pandemic, really that first pandemic summer when trip durations just skyrocketed at the system level, way above where they had been in any period beforehand. And that this pattern, even though it's choppier across the various planning districts, we see relatively similar trends, even just in the time series plots across all the trips that originated in any of these 8 different planning districts, which have vastly different socioeconomic and demographic backgrounds. For example, the Central District, which is Philadelphia's like CBD, very, very high income area in terms of residential property, much more Caucasian than the city at large. And compared to, say, for example, the West District, which has much lower property values, lower incomes, and is somewhere in the ballpark of 92 to 95% African American, right? But we're seeing quite similar patterns of change across these planning districts when it comes to trip duration during the pandemic. The other thing to note in this time series plot is just that essentially before the pandemic, once you control for seasonality, there hasn't really been any change in trip duration over time. And the other thing to note is that after that first summer and then kind of that first pandemic winter, spring, things look like they're returning to baseline. It's going to be really interesting to see as more data comes in, what's going on, and if we kind of just roll back to this initial trend line. Another important thing to note is that when we look at any of the season stuff, no matter what month of the year it was, during the COVID period, trip durations were higher. So this wasn't just a thing that happened when it was like nice outside. We're looking at people taking longer trips even in December, which is, I don't know how much time folks have spent in Philadelphia. It's not pleasant really to bicycle in Philadelphia in December, January, February. A lot of really cold rain, which has been shown in the literature to be not so conducive to cycling. Finally, this is the regression results, which I just want to highlight that the effect of the pandemic across all of these planning districts was positive and highly statistically significant. The range and values of the treatment of the pandemic covers a relatively large span from anywhere from 5 minutes to almost 12.5 minutes. But the main thing is the sign and the significance, which is consistent across the board, which we were surprised by and very intrigued by and interested in learning more about as we develop this further. The other thing to note is that this interaction term is negative, meaning that things are starting to return to baseline after the initial big bump of the pandemic moment. And then there's also a whole series of month fixed effects that I suppressed, but essentially what you see is that May and June are the nicest 2 months to bicycle in, and everything else is negative. So what do we conclude from this initial paper and what I presented to TRB is that the effect of the pandemic on trip duration is quite similar across really diverse planning districts in Philadelphia. We derive from this that bike share is able to absorb and adapt to major crises to the mobility system, like a pandemic where public transportation was shut down for a long time, where normal modes of mobility were impacted in many diverse ways. And perhaps more importantly, even that bike share can absorb these crises, that they can do so for diverse populations. what we derive from that second point is that that policy can going forward learn from this moment, right? And advance a more equitable agenda for bike share by building on these use patterns from the pandemic. If all of these folks who previously perhaps were less predisposed to use bike share exhibited relatively similar change patterns to other populations, higher income white populations that in the literature are more predisposed to use bike share in more intensive ways, then we should learn from this moment and really build on such use patterns by supporting these levels of use, perhaps by ways such as linking bike share stations in lower income parts of the city with new and safe physical infrastructure, which dovetails into the paper I'll present on now, and generally just by better serving the underserved. So a more widespread geographic distribution of stations, encouraging the kinds of financial, monetary, I guess, really actually systems that allow folks to use the bicycles without a credit card, for example, pay with cash, which already Philadelphia is developing and improving on those models kind of as I speak right now. Just to let you all know, since you've all supported this work, this paper is now in revision at Transportation Research Record. We're putting the final touches on the revision, and hopefully it'll be out the door soon. And I look forward to sharing it once it's published and has a DOI attached, and sending it around to everybody at CM2. So now to move into this work, which is a chapter of my dissertation that I'm developing right now. So this is much more of a work in progress, and I'm very excited to get to share it here. After I sort of, while working on, I guess, the study that we presented at TRB, and engaging with some work that Dr. Ryerson has been leading around, like, how do you cite safe bicycle infrastructure in the absence of observed data, I was wondering if there was something that we could learn from this really interesting bike share data during the COVID period around the citing of safe bicycle infrastructure. If there was some way that we could develop a means of analysis that was relatively streamlined, open sourced, using open data, and in blunt terms, cheap and affordable, to help inform planners who are interested in trying to put in new infrastructure to serve cyclists. What informs this line of work is a couple of things. First off, it's quite difficult to gauge where changes in cycling behavior happen, right? The existing data collection methods are pretty expensive. You either have to put pneumatic tubes underneath the road to count cyclists, or you have to pay planners or to go and stand on street corners and count cyclists going by, or maybe you have a volunteer mechanism, but that can be unwieldy in terms of collecting data regularly over time. To kind of compound this, it's even harder to figure out where bicycle change patterns might happen, right? This goes back to kind of Haight's really important thesis in the 1970s, which is that you can't observe where folks might use infrastructure if they never use it in the first place because it's unsafe, right? So to try to figure out, for example, where to put a bike lane based on where cyclists are already biking misses a whole range of spatial opportunities and infrastructure designs where cyclists might go, but they don't go there ever because they know that it's not safe, because the road is really fast, the intersections are totally convoluted, there's too many lanes of traffic, etc. What I suggest, and what I sort of give a test case of in this paper, is that the changes in travel behavior that happened during the pandemic can exhibit possible future alternatives, and from data gathered in that period, we might be able to figure out not only where change is happening, but where change might happen. And that's the methodological contribution I make in this paper. So I ask a couple of questions. Where do changes in bicycle use during the pandemic materialize at the root level? That's first. And where do what positive changes in use? This is going back to that first paper, which I define positive as increased trip durations concentrated across space. Where do these changes perhaps signal that we could improve cyclist serving infrastructure, make interventions to serve cyclists? And then the next step in the paper, which is not presented here, is what are some of the key social, infrastructural, and spatial predictors of these concentrations of positive change? This fits within the whole research design for my dissertation, which is all about the way that exogenous shocks affect different travel conditions or commute conditions. So in this case, it's about trip duration, the shock of the pandemic, and then measuring trip duration after the pandemic. The literature that frames this is that's like cycling and infrastructure to serve cycling has sort of developed rapidly and widely across the world, in particular, and also in North America. And that bike share is one of the really popular interventions as part of this more kind of a global advancing of cycling policy. By the distribution of bicycle serving resources, infrastructure, and bike share is unequal spatially and inequitable often in terms of reaching low income and high minority parts of cities, particularly in the United States. And I'm particularly indebted in this study to some of the work that Larson and Elganetti and Grease and Elganetti have been working on around trying to develop new raster GIS oriented methods to prioritize where infrastructure for cyclists could be sited. However, there's a very limited use of bike share data to inform bicycle infrastructure. That's generally the spatial analysis of bike share stuff is about bike share and about bike share stations, much less so about the way that bike share data can inform a larger conversation of cycling infrastructure in the United States. So I take 3 periods of time. I take May 2019, 20, and 21, and look at the differences in trip durations in May 2020 and 2021 compared to their origin station mean in 2019. That's sort of the key variable. And then use some raster GIS approaches to measure change over time. And I'll describe those in the next couple of slides. In terms of the open source, open data part, all the data is just provided by the bike share operator publicly online, and all the analysis is done using open source packages in R, primarily ST-Planner, which is the Lovelace citation. So what this kind of looks like in practice is you have an origin destination sort of matrix of bike share trips, which then send through a routing algorithm to actually figure out the spatial geometry of the trips where they theoretically happened in space based off of the optimization. The key thing to note here is that there's no GPS tractors attached to Philadelphia's bike share data, so you have to use some sort of routing mechanism to get the spatial geometry. And then you can assign those geometries any value. So this is like 10 random trips from 2020 and 21, and you can assign them the difference from 2019. And then translate those vectors, the vector geometries of the actual trips, into a raster environment. So that's this black and white one in the middle is just the trips converted from a vector data format into a raster format. But the more interesting thing is the last slide, which uses what's called focal statistics to sort of smooth out and the black, white, and gray trips into a more continuous space. And what I'm suggesting here in this approach, by taking the average of trips and the trips nearby them, we can start to figure out where change might happen, right? If a lot of really positive changes in trip duration as compared to 2019 concentrate in a certain space, that would be a place to, in my mind, look for where new infrastructure could be sited that would serve cyclists. The great thing about this raster approach is because the unit of analysis is constant, it's a constant geographic unit of analysis, you can do mathematical operations across the layers. Conditional statements, multiplication, division, subtraction, whatever you want to do. So this is like a yes-no resulting raster from 2 different time periods. And you can also turn any vector that you want into a raster format. So this is like bike lanes or census tract level data. And then finally, the next step is to turn this all into essentially a regular data frame to run regression analysis, where the unit of analysis is just the raster cell. And you can use like regular logit formats or hierarchical when you're modeling to do so. But this is the next steps, and I'll go over this one quickly. So the data comes again from the Indigo bike share system in Philadelphia. This is the station closest to my house in West Philly. The unit of analysis is the cycling route, and then how that translates into the individual raster cell. And the key variables that I'll share here are trip duration and then infrastructure. Going forward, there'll be socio-demographic variables as well, and some dependent variables that look at sustained change in 2020 and 2021 compared to 2019. Just some of the background, I took a random sample of trips in 2020 and 2021 to conduct this analysis. There are a lot of trips, so trying to convert 66,000 trips into one raster layer is computationally a heavy lift. So 6,000 trips looked to me to be relatively sufficient to gain insights into what was going on overall. And I use only the open source routing machine to route the trips across space. And the infrastructure data is also publicly available. So again, everything here, there's no proprietary data in any of the study. If you look at the trips as like desire lines or Euclidean routes, you'll find between 2020 and 2021, there's a more expansive distribution of trips in 2020 compared to 2021, which isn't so surprising because that first time period of May 2020 was like peak pandemic. And as my advisor, Dr. Ryerson suggests, there wasn't a whole lot else to do besides ride your bicycle around Philadelphia. Much was closed in that period. And if you look at these routes imputed over space as like actual cycling routes, you see the same thing, right? There's it's more concentrated across space in 2021. Similarly, we've seen trip duration that 2020 was a super outlier, right? So this is the cumulative density function plot of trip durations over the 3 years, and sort of just to see that the 75th percentile in 2020 is nearly twice the trip duration for the other 2 years. That's sort of the main point I want to get across here. And similarly, if you look at the duration, that difference for 2019 variable that I was talking about, you see also that 2020 was exhibited much more substantial differences than 2021 did. If you, with the data, if you convert it into the raster format, this is sort of what the distribution of the actual trips look like. And then this is the distribution of that focal thing, right? So you see that the values in the legend they kind of all gravitate towards the mean because you're smoothing out all the trips across space. And so those outliers, the 60-minute trip duration difference from 2019 or something like that sort of washes out, but so do some of the extremities on the negative side too. But this lets you sort of get a continuous surface where substantial changes in trip duration might concentrate across space in Philadelphia. And then it lets you do these really great prioritization schemas using the map algebra approach. So say, this is just to illustrate what the example might look like, that I wanted to prioritize like areas where in 2020, the difference in trip durations concentrate, like the concentrations of trip durations that were different from 2019 were greater than 10 minutes. And we can recode that as a binary raster where highlight all the cells where that is the case. Then in 2021, where the differences weren't so as stark, maybe we only want to highlight those instances where it's greater than 5 minutes, fine. And then a third one where if they're greater than 5 minutes in both 2020 and 2021, let's give those a value of 2 because that's like a sustained positive change. And then let's subtract out all the areas where there's bike lanes because we don't want to prioritize for new infrastructure areas where there's already bike lanes. And then that gives you like this is again, to illustrate a relatively simple priority schema where, you know, the 4s are the areas that are maybe highest priority and the reds are the areas of lowest priority. And then we can see how this sort of maps out across space. This is in the Francisville neighborhood. You can see over here, probably this was like not so much change from 2019 to 2020, and there was a bike lane over here versus up here with the 4s, right? This zone all over here, in my mind, at least based off the analysis, is probably ripe for some new intervention because there's a lot of increased trip duration, at least propensity in that area, but not probably unlikely that there's a fair amount of infrastructure. Of course, you'd have to like test this in the field and go out and like check it out, but as a way to determine sites for intervention, I think it's a relatively useful and clean mechanism. So the next steps are to develop models that predict this change in duration and that predict the persistent change. Check out the cell size and the criteria for aggregation that I'm using and see using a sensitivity analysis how this might change the results of the analysis. Maybe try to figure out how to orient the socio-demographic data to be more discrete rather than totally continuous across space, running into issues of like parklands having data for population, which doesn't really make sense in the regression context. And then whether or not to use like a binary, like I suggest here, or a continuous indicator for the change variable. And with that, I will wrap up and very excited to hear any and all questions that folks have. Thank you so much for your time.
Great. Thank you so much, Josh. That was really interesting. And thank you again also for talking about your presentation at TRB. And I'm glad that it was a successful trip for you.
Very much so. Thank you. Thanks again for having me. It was fun to get to give the talk. I appreciate it. Yeah. It's nice to get to share stuff that's in process. I like kind of not have to be able to share things that are like in the works. So
yeah, I think at least, I mean, rather not necessarily a question, but a comment is that with our BrownBags, since I'm kind of new to learning about transportation, since I started this role the past 2 years, we've done a lot of like lot of different types of transportation, but I'm always really interested in sort of the bike share stuff that we talk about, and sort of the inner city kind of travel and transportation issues. One, because my spouse is a cyclist. I feel like the cyclist crowd is a particular crowd of people that are becoming much more vocal about getting, represented and in safety transportation in their cities, in their communities. And he is one of those people. So I'm always kind of interested when I hear about what people are researching and talking about in terms of that. So it's always good to share that with our audience as well. So just as a comment, thank you for sharing this. I thought this was I was really looking forward to this presentation.
Oh, my pleasure. Yeah, Sandra, I think you're absolutely right. The cyclist crowd is definitely its own crowd. If you're at TRB, the cyclist committee meeting is definitely, what's the right way to say this, a little bit more aesthetically casual than some of the other spaces. And so, yeah, it's definitely its own unique ecosystem. So.
There's always a pant leg stuffed in a sock kind of thing, I think is
yeah, exactly,
a marker of a commuter on their cyclist.
Totally.
Okay.
Hey, Josh, thank you for your very interesting presentation, although it's very brief. And looking forward to read your paper when it comes out in detail. And just a couple of questions out of curiosity then.
Sure.
So your study sample includes only those stationary shared bikes, right?
Yeah,
with
there are
stations.
Exactly. Yes, that's exactly.
So that means that the origins and destinations, the final origins and destinations are fixed. People have to return bikes to the designated stations.
Yes.
And I wonder what you're thinking or your thoughts will be if you apply the same methodology and research question to the non-stationary shared bikes, and the geographical scope of the bike uses may differ from those stationary bike users.
Absolutely. It's a fantastic question, and to a certain extent, the project would be even better if I had access to good non-stationary data, right? The Philadelphia system is strictly stationary. There are no dockless bicycles yet in Philadelphia. My understanding is that in Austin, it's a mix. Is that right? There's some stations and some dockless, right? It's like Washington, D.C. is a similar thing. But here so far, there have been no entrance into the market of dockless yet.
I see.
So part of the point I make in this paper is that to a certain extent, it's like, this is an approach that if you have the most sparse data you could imagine having, right? And essentially like no additional resources beyond a computer, like a basic machine, right? Here's like a relatively interesting and meaningful analysis that you can do to inform infrastructure setting, right? I sort of had in my head the planner working at the city of Philadelphia's office trying to be like, what are we going to do about bike lanes? And like, this is what we have, right? Is like our regular machines and this data. If I had if there was data on a dockless system that was provided in a way that could ensure confidentiality, it would be an amazing resource to this kind of study, because then you could compare the imputed routes to the observed routes and see what the difference is in the ultimate analysis at the end. I think it'd be a fabulous thing. Washington would be the best place to do that because they have both. So, or Austin, I guess, right? But the big problem with the GPS stuff is that people hold it very close to the chest because it has big confidentiality issues.
Right. Yes. The Austin data you can download from Austin's website, but the challenge is that they truncated longitude, latitude digits. I noticed quickly from your slides that you also only show like a 4 digits after for longitude, 5 or something for latitude.
Right.
And you might have a more accurate, the original for the doctor station, I don't know.
Right.
If it's only a 4-digit of after longitude, for the longitude, and 5 after latitude, then all you can get is somewhere around like a 100 by 100 meters square for the location, for the stop of each bicycle activities. So that creates some problems, but well, that's the privacy issue that the data providers have to take care of.
Yeah.
And then, so I assume that between 2020 and 2021, the two comparing time periods, and there were no changes in bicycle supply in terms of stations or the amount of bikes supplied.
Right. So this is a great question. So what I did is I limited the data to the 2019 spatial distribution, right? So I only selected trips that originated, and I keep saying destinated in my head, which is not the right word, but that originated and ended in stations that were present in 2019. There was a system, there's a tiny system expansion in 2020. There was a substantial system expansion in 2021, right? And if I would have included those data, the results look really weird because it just essentially tells you that you should prioritize only infrastructure by the new stations because there's no baseline to compare it against, right? So I limited the sample just to the 2019 range of possibilities.
Well, the last part of my question was that you may have talked about a miss or you have done that but not presented today. And did you look at the time of day variation? You show the day, kind of a seasonal, right? The months of the year.
Right. So for the first paper, we aggregate just to the day rather than the time of the day because there was it got really unwieldy when we were trying to do like from 2016 to present longitudinal like hourly data got pretty unwieldy. I think this is for the second paper though, it's a really interesting idea to maybe do a sensitivity analysis based off of time of the day as well for the trips. And I have not explored that yet, but I will definitely look into that as I'm preparing this paper. That's a great idea. Thank you.
Great. Thank you. I will stop. I do not want to dominate the Q&A session.
I really appreciate the questions. Thank you so much.
I guess I also kind of had a question. As you had kind of said that you wanted to kind of develop something that would be minimum, like, not minimum, but like the simplest way to actually get some of this data for a planner. I was kind of thinking also, I'm sure that there are cyclist advocacy groups that would really be able to use this data when they go into talking with their city council and all those kinds of planning events where there's open forums for them to push for that kind of change in infrastructure in their neighborhood. Was that something that you might, or that you talk about or consider, if you could talk?
Yeah, I mean, and it's definitely it's a great question. And it's definitely a driving force, I would say intellectually and emotionally in our lab. So Megan, I hope this is okay that I'll share this, but Dr. Ryerson used to bicycle both of her children to their preschool, and then would bike this extra cycle, this really long bike on the back to Philadelphia, and that's Philadelphia, to Penn every day. And this is when I first started working in the lab in 2017. This was like really a regular part of our meetings, was rolling up on this big bike. And she testified at city council in Philadelphia around the need for there to be like more robust bike infrastructure in the neighborhoods that she was commuting through, and gave this illustration of like her example, which is like, not only is it like a person on a bike, right, but this is her and her two, like at that point, like 4-year-olds, 5-year-olds, right, who she was bicycling around. So that realm of it, like all of our work, so the work that we published in Accident Analysis and Prevention, which uses eye tracking data as a means to try to save infrastructure, and this work is like totally informed really by that advocacy point, right? which is like in a universe where there's a limited amount of resources, like how do we come up with data-driven tools to cite infrastructure in an equitable way? And really it's personal for a bunch of us, like, you know, like Dr. Bryerson's a cyclist and she bicycled around her children. I bicycled my kid 3 days ago in the trailer around, like I'm a cyclist too. Like it's close to home for all of us. And we also have our colleagues and people who graduated out of the lab who are in the applied ends of this world and who work in the advocacy organizations who like need the information too, right? So we're kind of always working on these two fronts, which is like, how do we push new methods and methodological experimentation, and how do we bring those methods like down to earth and apply them into like sort of like urgent policy problems.
I guess I had another question. The paper itself is focused really on, as you said, the shock, I believe was the term that you used, of the pandemic and how that kind of informed the research question that you're posing. I guess my question would be kind of like I mean, obviously, like this is something that has been experienced worldwide. So again, very useful in that impact, but could this be applied for other shocks that could, you know, be experienced in different cities, like hurricanes, tornadoes, that kind of, you know, things where infrastructure can be changed for a significant amount of time?
Yeah, that's a great question. We were just working on a paragraph for the revision about the resiliency natural disasters framework. I think that's definitely one. Natural disasters are an interesting one in terms of comparison to the pandemic, because like often natural disasters make it so that it's really hard to bicycle, right? Like flooding, intensive heat, anything like that, kind of hurricanes, et cetera, make it really quite hard to bicycle, right? And so some of there's a couple of papers that have been published looking at like after Hurricane Harvey and stuff, what happened to cycling in those moments. And generally it like went down a lot, right? Rates of cycling went down a lot immediately afterwards. The pandemic's interesting because there's huge variation city to city about what happened, right? So like in New York and Chicago, for example, there was a big drop and then a massive rebound that first summer. In Philadelphia, there was no drop. It just went up for some reason, right? And why these different places varied, even though they don't exhibit that different of typologies in terms of COVID response or the characteristics of the bike share system is interesting. So the best example that I have to compare the pandemic to is when there's a transit strike, right? That's like this moment where there's like a big, super clear cut point, but none of the weather stuff or the environmental features would make it hard to bicycle, right? And so folks who've done a little bit of work in London and in DC, it was around I don't know if folks were in Washington a couple of years ago, but there was this huge track maintenance program that just like shut down DC Metro for a really long time. And in London, there was these strikes where like the tube was shut down totally for multiple days. And folks studied that, and the bike share, particularly bike share stations that were close to transit stations, all saw like really big boosts in use. So that's the best, I think that's the closest thing to learn from the pandemic. But I think this idea that we can learn from the pandemic and apply it to disaster frameworks and resilience frameworks more generally, I think it's definitely a really great next step.
Great, thank you. Well, I'm not sure if there are any other questions, but if not, I mean, we have taken up enough time, I think, in terms of questions and everything. So once again, Josh, thank you so much for your time.
Thank you so much.
Like I said, we'll be sharing this on the School of Architecture YouTube channel. So
Awesome.
We'll be sharing that this week, hopefully within this or next week, have it posted online. Yeah, and our next BrownBag presentation will be on March 24th. We'll be having a student from Texas Southern University doing a presentation, so we'll be sharing that information as well. So I'll go ahead and say once again, thank you so much, everyone. Appreciate everybody's attendance. Have a great afternoon and goodbye.
Thank you, Josh.
Bye. Thank you all.